So the intermediate value theorem. So if f is continuous on an interval a to b, then for every value m between f of a and f of b, there exists an x value c such that f of c equals m, where c is between a and b. Okay, what I want to do first is just kind of work through what all of that means and how we can use a graph to just understand all of those words. So f is continuous on an interval from a to b. So this is an x interval. So I need you to go on the x-axis and find a and b, and it doesn't matter where you put them. I'm just going to, for ease, because of kind of where we're hitting down here at the end, I'm going to put a like less than b. They can both be on the same side. They don't have to be. So I'll grab I'll grab a and I'll grab b. And then I need to find, right, a function that goes between these two. So find some place where you have f of a. So I just grab mine up top there. So there's my f of a, and then grab a different point for f of b. Okay, so I'm kind of set up, and I need f to be continuous. So now I need you to draw a continuous graph, a continuous function, right? Don't fail your vertical line test, but draw a function between f of a and f of b. And it can go above or below. You can do a straight line if you want, make it curved. But here's what the intermediate value theorem says, that your function will take on every single value between f of a and f of b. And not only will your function take on every value between those two, so grab just some arbitrary number in there, m, but it will do it at an x value that's also between a and b. Okay? So your function will take on every single value between f of a and f of b, and it will do that at some x value that is between a and b. Intermediate value theorem. Now, when we can use this is for finding zeros of polynomials or other functions. Okay? So f is continuous on a to b, and f of a and f of b have opposite signs. Okay, so now we're going to grab a and b again. But now I want f of a and f of b to have opposite signs, and that means one's positive and one's negative. Okay, so it doesn't matter which one's which, just, right? Find your f of a. And now, since I made my f of a positive, my f of b has to be negative. And f has to be continuous between those two, so draw some kind of continuous graph. Okay. So the idea, this is a corollary, right? So it's just a bonus from our intermediate value theorem, right? That there exists some value between f of a and f of b, 0, right? If they have different signs, then 0 is somewhere in between, where, right, f of c equals 0. Where you get an x-intercept. So you can't go from being positive to being negative without going through a 0. Okay, well, let's go ahead and practice our intermediate value theorem. So let's show that, okay, so I've got a function here. Y equals x tan x is equal to 3/4 for some x value on the interval 0 to pi4. Okay, well, let's see. Let's look at this with a table. How about that? So we're going to go ahead and draw a table, x and y. And I have 0, right? My x's go between 0 and pi4. So y, right? This is y of x. So we're finding, like, you're at your point A and your point B. And we're just going to show that 3/4 is going to be between y of a and y of b. So if x is 0, what do we get? We get 0 times tan 0. Well, tan 0 is also 0, so all of that is a 0. Okay, so f of a equals 0. What's f of b? So for f of b, I'm going to have pi4 times tangent of pi4. Okay, well, tangent of pi4 is 1. If you want to do that on your calculator, make sure you are in radian mode. So that was the mode button right here. And then you want to make sure you're set up at radian mode. If you're on degree, go ahead and come on over and fix that. And then, what is it? I've got tan pi fourths times pi fourths. So 0.7854 or so. Okay, so f of b is 0.7854. Okay. So what we're trying to say is that our function x tan x at some point hits 0.75. Well, right, that's our m value. I don't know my c. I'm not actually asked to find c, so I'm not going to. But I know that somewhere between 0 and pi fourths, my function is going to pass through 3/4 because 3/4, 0.75, is between 0 and 0.7854. Right, so since m is between, right, 0 and 0.7854, backwards capital E is there exists a c on that interval 0 to pi fourths such that s dot t dot f of c equals 3/4. Okay. Intermediate value theorem. So now let's use it to show that a polynomial has a 0. So polynomials are definitely continuous. I guess I should have talked about that our x tan x is continuous on that interval, right? So that was one of our caveats for the intermediate value theorem. So the graph of tan x, just in case you needed to remember, so tan x itself is this kind of a shape, and it has its asymptotes at pi halves and negative pi halves. So, and multiplying it by x, so x is continuous over all real numbers. So a product of two continuous functions, also continuous. So tangent is continuous, right, between 0 and pi fourths. X is continuous on 0 to pi fourths. So the product of them also continuous, right, at least between 0 and pi fourths. Okay, polynomial is continuous over all real numbers, so that's awesome. So we just need to show that our polynomial has a 0 somewhere on the interval, right, the x interval 1 to 3. So this is the corollary. So I need to show that p of 1 and p of 3 have opposite signs. Okay, so what is p of 1? So I got 1 cubed minus 2 times 1 minus 5. Okay. 1 minus 2 minus 5, so negative 6. So that one is negative. I didn't really care that it was negative 6. I just really cared that it was negative. Okay. Now what is p of 3? Again, in order for us to show definitively that p has a 0 between x equals 1 and x equals 3, p of 3 has to be positive. It has to have a different sign. So p of 3, 3 cubed minus 2 times 3 minus 5. Is that positive? Well, I got 27 minus 6 minus 5. Okay, yes, that's definitely positive. Cool. So somewhere between 1 and 3. Now, there's something called the bisection method. We could try to narrow this down, right? Try to narrow the 0 down. So between 1 and 3, that's a pretty big interval. So is it between 1 and 2 or between 2 and 3? How could we decide? Sure. So let's go ahead and find p of 2, right? And see if that's positive or negative. That will help us determine, right, where it changes signs. Is it between 1 and 2 or between 2 and 3? Well, what is p of 2? What do I got? 8 minus 4 minus 5. That looks like that is negative 1. So p of 2 is still negative. P of 3 is positive. So I know that the 0 is on the interval between x equals 2 and x equals 3. We could right to right and narrow it down again by, again, cutting it in half, right? Taking 2.5 and seeing if that is positive or negative, right? Just to try to figure out where exactly that's going to change signs from being positive to being negative. Okay, so that's how you can use your intermediate value theorem.